this is what's given. We need to find a certain value of P that does the following. No matter what the value of P is, 0.8, 0.8 is always in this shape. If P is 0, then we just have the horizontal line y equals 8. But in any other case, px squared plus 8 would be a parabola with vertex at 0.8. This is for negative values of P. And here is the line 4x plus 2. And we have to find the value or values of P that produces this connection. Sometimes the line could miss the parabola. Sometimes we could have two intersection points. So we just need the tangent line here. Let us call the function px squared plus 8. Let us label it as f of x and the tangent line as g of x. And we're going to introduce one more unknown, which is why we're going to need two equations. And that one more unknown should be the x coordinate of the point of tangency, because that is where the derivative needs to be evaluated. So we need to be able to express the slope as a derivative. For that, we need to express the x coordinate of this point. Okay. So the y coordinate is, because the point of tangency is both on the line and the parabola, let's just use the line. It's simpler to express the y coordinate. And now we're going to have two equations. One of them will express the following: f of a equals to g of a. So both functions contain the point of tangency, and f prime of a is g prime of a. And that should be the slope of this tangent line. So the derivative of f of x is 2px, and the derivative of g of x is just 4. So here are the two equations. F of a equals g of a is pa squared plus 8, that's f of a, equals to g of a is 4a plus 2. So that's an equation linear in p, quadratic in a. And for the derivative, if the derivative of f 2px is evaluated at a, that's 2pa, that should be the same as 4. Okay, this is a quadratic system with two equations and two unknowns, so we should be able to solve it. And I see a shortcut here that might cut down on the work considerably. If we simplify the second equation by dividing by 2, we get that the product AP should be 2. And PA squared is AP times A, right? This is, so the first equation will look like this. PA squared is going to be A times AP plus 8 equals 4a plus 2. This is the equation. And now we're going to substitute 2 into AP. So then 2a plus 8 equals 4a plus 2. That's a really nice linear equation now, right? So 2a is 6, and therefore a is 3. Recall that a was the x-coordinate of the point of tangency. We have to find p. But if we go back to the substitution we used, AP equals 2, now we know that a is 3, so 3p equals 2, and therefore p is 2/3. If we have time, we should check. But this is the end of the problem. F of x, the parabola was px squared plus 8. We think that that's 2/3. So f of x, we think, is 2/3 x squared plus 8. And we think that the point of tangency A was 3. So let's come up with the equation of the tangent line drawn to this at x equals 3. F of 3 is 2/3 times 9 plus 8. 6 plus 8, that's 14. And f prime of x, we differentiate this, so that's 4/3x. Therefore, f prime of 3 is 4. So the slope is 4. The point of tangency is 314. So m is 4, and the point of tangency is 314. So we have 4 times x minus 3 is y minus 14. So 4x minus 12 is y minus 14. So y is 4x plus 2. So indeed, the tangent line is 4x plus 2. So our solution is correct. Thank you for watching.